Hey everyone, it's that math magician. On this video, we're going to take our first look at prisms. And hopefully at the end of this video, we'll have covered a nice introduction to what prisms are, and hopefully you'll have a solid definition to work with as you work through future examples. So let's go ahead and look at a bunch of examples for prisms so we can get a nice, solid definition. Now I'm looking at these shapes here, and I'm realizing that these are shapes. They are not prisms. These right here are two-dimensional shapes. We have a couple of polygons, a rectangle and a triangle, and we have a circle. Now these are not prisms, but this is a great foundation for us to think about what makes a figure a prism. And what a prism is that you start with a two-dimensional polygon, such as a rectangle, triangle, circle. You could even do a trapezoid, a parallelogram, a hexagon, an octagon, any two-dimensional shape. And all you do is you take that shape and you add some height to it. Imagine having this circle here and stacking a bunch of circles on top of each other. What that would form is a three-dimensional shape where you would have a circle on the bottom, a circle on the top, with now a height involved. That's what a prism is. And I actually do have a couple of examples here to show you of prisms involving those shapes there. Now we see that when I have my rectangle here on the left-hand side, right below it, I have what we call a rectangular prism. Notice that the base shape on the bottom is a rectangle. And that is just a bunch of rectangles being stacked on top of each other to form this rectangular prism. Also in the middle there, you'll see that we have taken that triangle and we have done, again, very similar to what we did with the rectangular prism, just took that triangle and started stacking a bunch of layers on top of each other, forming that triangular prism. And then finally, as I mentioned in the first example, we see that circle there on the bottom of the shape. That right there is what we refer to as our base shape. We're stacking up the circles. Imagine having a stack of quarters or dimes, right? Those are circular. Stacking, stacking, stacking. You would create what we call, not really a circular prism. This has a fancy name. We call this a cylinder. And again, notice that for prisms, one of the key facts about prisms is that they have the base shape on the bottom and the same base shape on top. And that is super important for what defines a prism. You got your base shape on the bottom, you add some height up, so you're creating these sides around the prism to the base shape on top. And that essentially is what a prism is. Now we can do a lot of things with prisms. One of the things we can do that we can't do with a two-dimensional shape is that we can find the volume of these prisms. And what volume refers to is it refers to basically filling up the inside of that prism. How much can that prism hold? For example, I have a coffee cup here. This is not a prism, but we can still use this coffee cup as an example for volume. Right? When I have my cup of coffee and I'm pouring it in here to fill this cup up, it's filling the volume of my coffee cup. Now this sort of resembles a cylinder, but I have two different circles here, one on the top, one on the bottom, that are different sizes. So this wouldn't qualify as a prism, but we can still refer to volume as filling up this figure with what's inside. So that's one thing we can do, is volume. The other thing we can talk about is surface area. And surface area really sounds exactly as it seems. When we're trying to find the surface area of one of these three-dimensional prisms, what we're really asking you to do is to find the volume, to find the area, of all the sides. So looking at that rectangular prism there, we would have to find the area of the top part of the box, the bottom part of the box, and then the four sides going around that prism. So those are the main two things that we can do with prisms. Finding the volume basically how much is going to fit inside the prism, and then finding the surface area, which is really finding the area of all the sides. And in my next couple of videos, I will go through exactly how to find the volume and the surface area for many different types of prisms. It's that Math Magician, and I'll see you on the next video.